Mac 248, production procedures. After the spring break, we're back on the 14th of April. What did we learn today? Well, we started chapter 12, which is about Six Sigma, and a lot of the people in this classroom are going to hope to go to GE either immediately or one day to work in the jet engine plant. And Six Sigma was developed by them and is really a process that they champion. I had you read pages 191. We almost made it to 199, but not quite. So please continue reading chapter 12 and get all the way through it if necessary, but certainly up to these parts that we're going to talk about next. After that, we just went over the Six Sigma basics. I put two very primer type videos on the Blackboard site. I showed one of them about 5 minutes, which was just about the basics of Six Sigma and how it would apply to a little small business like either a plant manufacturer, a person who has a planting house, a landscaping business, and then there was nuts and bolts. And it just showed how they could focus on improving and using the Six Sigma processes, and I thought it was really good. So watch those too. All right. So Six Sigma basics. What are we talking about? I went through the book. I got to about page 199. Six Sigma. This is the Greek symbol for sigma. It's like a weird looking O with a letter on the top of it. We have to know what's meant by 3.4 defects per million units or opportunities. So a unit is each one of the product that you're selling. All right, that can be one part or it can be a whole bunch of parts brought together. A defect is anything that does not meet customer requirements or anything that is out of specification is a defect. All right, and an opportunity is any opportunity to make a defect. So every time the part goes through this machine, you have 1 million units, and 1 million units go through this one machine. If there are 3.4 defects coming out of that process, then this is in Six Sigma compliance. 3.4 million defects per opportunities to make a defect. All right, Deming was the father of total quality management, went to Japan and was listened to by them. Came back to the United States later on and started the total quality movement, total quality management movement, where he said that management was responsible for 94% of quality problems. Their attitudes and just their dumb decisions. I read recently that 80% of most managers that are in contact with people do not know what they're doing. Only 20% of managers of people are effective at managing people. All right? I went over the six dimensions of quality, or the 6 quality specifications. And I remember saying, let me get the book back, that my favorite one was perceived quality, the one at the very bottom. When your customer perceives that you have a quality product, he will pay more for it. So companies jealously guard their quality specifications, but especially that one of perceived quality. This is on page, anyway, yeah. So then there were the 4 costs of quality. Anyway, the quality specs were performance, features, reliability, serviceability, aesthetics, and perceived quality. Those kind of things are going to be on the test. The 4 costs of quality were appraisal cost. What does our inspection department cost? Prevention cost. What does it cost us to get everybody together to find out why we have so many defects? Internal failure costs. Costs for defects that happen before they get in the customer's hands, and external failure costs, which are much more expensive, are ones that made it all the way to the customer. The worst kind of defects and the most expensive to us. Then I talked about the DMAIC focusing steps in Six Sigma, and I went over here and compared and contrasted them with the theory of constraints. And there are a lot of things that are the same here in this chart. There are some things that are a lot different, but they are both ways of instituting continuous improvement into the product, into the plant, and into yourself. You should have, when you leave here, and you having taken this course, you should have an attitude of continuous improvement. Later on, we went over the paper requirements. I talked a lot about don't give me a sob story, don't tell me personal stories. Make this be about a production process. I handed out the sentence from the syllabus that spells this out. The paper is to be based on outcome number 4 above, and outcome number 4 was this. Write a detailed report that describes a complete production process. Something has to get produced, and then how you would relieve or minimize the constraints and bottlenecks of that process with a bias towards small, little, incremental improvements. This will get you to a 3 to 4 page paper. If you're trying to do major improvements to something or save the world, that's going to be a thesis paper and not part of this course. So please try to keep it not a personal thing. Minimize your use of I, me, or mine. This does not say that you can't have I, me, or mine in your paper. Just try and minimize it. Thank you, and we'll see you Thursday. Please read chapter 12.